Now, let me do this question by three methods. And this is not a very easy question, so I try my best, try to well explain. Method one. Method one, I guess, is straightforward. Directly do as it says. It says that f of x equal to this one. Then I find f of x and I put it into this integral. Then I find the result. That's method one. So I start with f of x is equal to from 2 to e to the x log of t dt. Now I omit some details, but I believe that you have done those things. For example, how to integrate it, log t dt by parts, right? So this is a t log t minus t. That is the integral of log t. And you can fill up the details. And 2 to e to the x, okay? And this one is equal to e to the x minus 1 minus 2 log of 2 minus 2. Minus 1, right? If I take it to out, sorry. Okay, that is the f of x. Then I put this one into the integral, therefore we can find log 0 to 2 log x times this. This is f of x, e to the x, x minus 1 minus 2 log 2 minus 1 and the dx, right? So, as I said, method one just do directly as it says. Then this one is equal to integral from 0 to log 2. This will be x squared minus x e to the x dx. Right, that is the first part, minus integral from 0 to log 2 and 2 log 2 minus 1x dx. That is the second part. This is just simple to follow, but a little something to write. So this one I can use by parts, right? So this one is d e to the x. I can use it by parts. So this is x squared minus x times e to the x, and from 0 to log 2, and minus integral from 0 to log 2 v du. V is this. Du is the derivative of this one is 2x minus 1 and dx. Okay, that's take care of this one. And for this one, it's easy. It's just minus 2 log 2 minus 1 x squared, right? From 0 to log 2. Okay, just simply straightforward. Then this one equal to, equal to log square 2 minus log 2. This is 2 minus this thing 0. Right. Nothing. For this one, by parts again, the ex dx is e to the x. So this is equal to 2x minus 1 times ex from 0 to log 2 plus, because negative, integral from 0 to log 2 ex times this derivative, which is 2 e to the x dx, right? Minus 2 to cancel out. But this is a log square 2 multiplied by log 2 minus 1. Oh, just a simple calculation. Okay. Okay, then this one is equal to well 2 log square 2 minus 2 log 2, right? This one is a 2. 2 times the 4 log 2, right? 4 log 2 minus, this is 1, this is 1, this is negative, so it becomes positive. And this one, is plus 2 e to the x from 0 to log 2, right? Minus log square 2 log 2 minus 1. Okay, this one is equal to 2 log square 2 minus 2 log 2 minus 4 log 2 plus 1. This is a 4. This is a 2. This will be log cube 2, cube log 2 plus log 2 square. And some tedious algebra. So this is negative natural log 2 cube plus 3 log 2 square minus 6 log 2 plus 3. So that is the result for this. Method 1. Method 1, just a straightforward calculation, you know? A little tedious, but straightforwardness. Okay, this is the method 1. Now the second method, the question is where was the question? I lost the question. The question that given this is the question. Given e f of x is equal to 2 to x log t dt, right? We are looking for 0 to log 2 x f of x dx. Okay. Okay, method 2. Now, method 2, Well, I write this one. F of x is equal to from e to x to 2 log dx dt. Okay. Then I replace this one there. I get this is what I want, right? F of x dx, which is equal to negative 0 to log 2 and e to x 2x log t dt and dx. If it becomes double integral, now if you look carefully at that, it's the integral function is x log t, and we integrate over a certain region. If we draw a graph, okay, now let me do this way. Okay, this is a graph. This is x. This is versus t, right? Now, x is x from 0 to log 2. So this is 0. This is log 2. That is the range of x, right? And t is from e to the x. Well, where is the e to the x? E to the x. So this is 1, right? Yeah. This is t equal to e to the x, right? And this is 2. Okay, t is from this function to 2. So eventually this is my region. Now log 2 is here. This is 2. This is log 2, right? Yeah. Sorry. This is log 2. Okay, let me repeat again. X is from 0 to log 2. T is from e to the x from this to 2. So eventually that means that double integral, this is a double integral over region omega, right? This is omega. The function is x log t, right? ds, that is the integral. We integrate this function over the region. This is the region. That's a double integral. So we can choose whichever to do first. Now, I choose to do x first. If I choose x first, then I do t later. T is from 0 to 2, right? And x is from, where is x from? X is from 0 to this curve. This curve is, x equal to log t, right? So log t, yeah. And x log t and dx dt. Well, I hope everything's okay. Now we do x first, so this will be log t times x squared, right, from 0 to log t, and dt. So this one is going to from 0 to 2, from 1 to 2. This will be, I'll take half out, negative half. This will be log q t, right? Yeah, and dt. Yeah, everything's clear now. Now then I use by parts, right? Use by parts. Minus half. This is u. This is dv, right? So it becomes u dv. So this is v. This is u. From 0 to 1 minus integral from 1 to 2 v du. V is this, du is 3 log square t times 1 over t dt, right? Yeah. And this one is equal to, well, lots of calculations. This 2 cancel with that 2 becomes a negative log cube 2 plus, become plus, right? This is negative become plus. Log 1 is 0, therefore it's gone anyhow. Then this one times this one is 3 over 2. You can change it positive. And t cancel out. It says integral log t square, log square t dt. Use by parts again. By parts again. Okay, this becomes v. V is t, right? Log square t from 1 to 2 minus integral from 1 to 2 v du. This is v. Du is 2 log 2 from 1 over t dt. Yeah. This one is negative log cube 2. This is 2 log 2 square, right? Becomes 3 log square 2, and then 0 is gone. For that one is minus 3 halves. This is log. This is 2 cancel out, sorry. There's no 2. 3 halves times 2 is 3. And becomes t log t from 1 to 2 and plus 3 times this one again. So this is a t and 1 over t dt. So 1 to 2. So I end up with the negative log 3 log cube 2 plus 3 log square 2. This would be 6, right? Minus 6 log 2 log 2 log 2. Log 1 is 0 is gone. This will be 3t plus 3t from 1 to 2. Yeah, so this one is finally equal to negative log cube of t plus 3 log 2 square minus 6 log 2 . Yeah. This is 6. 6 minus 3 is plus 3. So, okay. That is answer by method 2. I think, yeah, same answer. So, okay, you can go over details. Sorry, there's some lots of details in here. I think I did it correctly, but it just repeatedly by parts, repeated several times by parts. This is a nice way of doing by double integral. Okay. The third method, well, question is given, f of x is equal to from 2 to e to the x and dt. Okay, we are looking for from 0 to log 2 f of x dx. Now, method 3, I think it's a very clever method. The method is so clever that it starts with by parts right away. Well, it's from 0 to log 2 f of x dx squared. Now, to maintain an equal sign, so they're equal to 1/2, right? So this is 2x dx, so it makes x dx after half, okay? Yeah, then you see we can use by parts. By parts, this is 1/2. This is u, this is v, right? So uv is this, f of x, and from 0 to log 2, and minus half v du. V is this. Du is f derivative, right, with respect to x and the dx. Yeah. So the first part will be 1/2 log square 2 and f of log 2 minus 0, right? This 0 is gone. And minus 1/2 0 log 2 and the f derivative of x dx. Now, do one by one. Now, what is f of a log 2? You know that given f of this. This is f of x. Therefore, this will be equal to 2 to e to the log 2. That will be f of log 2. And then log t dt, right? And e to log 2 is 2. So from 2 to, yeah, from 2 to 2 is 0, right? And from 2 to 2 is 0. Therefore, the whole thing is 0. Minus integral from 0 to log 2. Now, what's f of prime? This is f, right? Therefore, f prime of x is equal to log this, right? Log this. But don't forget, this is not x. This is itself is a function. When you take a derivative, you apply the chain rule. So what about this derivative, which is x? No, which is e to x, sorry. Yeah. So this one is x, this is e to the x. That is my f prime of x. See? Because this is not a single x, this is a function. So when you take a derivative, you have to use the chain rule, so we have to take the derivative of e to x, then actually end up with this. So this will be, no, I'm missing x squared here, right? So this will be x cubed and e to the x dx. Okay, because of this, x squared times this, it becomes x cubed. And obviously that this could be done by parts. You must have done when you learn the topic of by parts. This is just repeating several times to get. So this is 1/2 uv. U is this, v is this, from 0 to log 2, minus become plus 1/2 from 0 to log 2 v du. This is v, right? This is du, 3x squared dx. Then this one is equal to negative log a cube of 2, right? Times e to the x will be 2. And minus this is 0, okay, so plus. Now, this will be, take 3 out, and uv, right? This is v, this is u, from 0 to log 2, minus v du, integral from 0 to log 2, v is x squared, right? Now, v is e to x, right? Because ex dx is a dex. That is my dv. So, three is taken on, or this is e to the x, v, this is v, du will be 2x dx. Yeah, that's correct. And then this is equal to 2 to cancel out, negative log a cube over 2. And plus 3 over 2. This will be log square over 2. This is 2, right? Times 2 again. And minus 0. And this is 2 is cancelled out, so it's a 3. So integral, this is a ex dx is a dex, right? Same thing as this one. So u is x. Yeah. U is x. U v from 0 to log 2 minus integral v du. V is this. Okay. Du is a dx. Yeah, I have to be very careful. So this is minus cube of log 2. This to cancel with that one is 3 log square 2. Now this will be, this is 2, right? This is 6, minus 6 log 2. Yeah. And this will be plus 3. This is e to the x from 0 to log 2. So this will be negative natural log 2 cubic log 2 plus 3 log square 2 minus 6 log 2. This will be 2, it's 6, right? And minus 3, yeah. So finally we get to this result, minus cubic log 2 plus 3 log square over 2 minus 6 log 2 plus 3. That's exactly the same result in the previous two methods. But this method is I think it's a fantastic, very clever method. Start with the by parts right away. This question, I think, is very good, particularly for those who are taking the basic calculus course. It's a very nice way. I suggest that you can go over by yourself. These three methods. Thank you.